Good evening. This is Mr. Benning, and we want to go over the community ecology section that you're going to look at today. Um, some of the things that we're going to look at is that we're going to understand that organisms are all limited by factors within their environment. And from those factors that we have, um, we can talk about primary and secondary succession. Um, Not only that, is that we're going to look at how biotic and abiotic factors affect the distribution of organisms. We're also going to look at the primary and secondary succession, how they're going to move around. So let's go ahead and get started. All right. Give me 1 second because I forgot something. Okay, a biological community, I do apologize for that. A biological community is a group of interacting populations that occupy the same area at the same time. So we're talking about all the different distributions of people, the distributions of different animals, different things like that. Um, So that one thing we also got to remember, because all of these interactions that's going on, that all the organisms interact on one another or rely on one another to keep the ecosystem in balance. So everything we talk about balance, this is what we're going to look at in this section, kind of talk about what happens if a normal community stays in balance, what balance kind of looks like in a community. So like one thing that happens, or just looking at this stuff here, a wolf has a thick winter coat to allow them to live in frigid winter conditions. I mean, they need those thick coats to keep themselves warm. Not only that, the color of the coat itself allows for camouflage, allows that wolf to hide in the snow to help it sneak up on its prey. And not to mention, a cactus has the ability to retain water, and that allows the plant to live during long droughts. So if there's a long drought, the little spines on the cactus allows it to pick up water from the atmosphere to help it survive and store water for long periods of time. So as we keep going along, you notice that in these places there's not a whole, or the organisms are different. You look at the winter, you've got the pine trees, you've got the wolf here. Again, the population of things are not very much. It's just like it is in this forest or this desert here. There's not a lot of animals here. There's some cacti around, but not a lot of animals. Because of those conditions, it limits what's actually happening in those ecosystems. So when we talk about this, we talk about a limiting factor. So kind of define it a little bit. A limiting factor is an abiotic or biotic factor that restricts the numbers, reproduction, or distribution of organisms. So we're looking at things that are around that kind of restrict what's going on in that particular ecosystem. So anything that you can think of, whether it's living or non-living, or an abiotic or biotic factor, can be a limiting factor. So remember that abiotic factors are the non-living factors, and the biotic ones are the living factors. if you want to kind of just make it easy. And so, and some of the abiotic factors kind of give us a little bit of an idea of what's happening. So we get into what is called the range of tolerance. So what we're looking at here is that for any environmental factor, okay, that we're thinking of, is that there is always going to be an upper or a lower limit that defines conditions, meaning weather, temperature, that a specific organism can live in. And so we're going to look at some specific zones of that range of tolerance. But the part that where they best survive is called the optimum zone. The optimum zone is the portion of the range of tolerance where the greatest number of species can survive, grow, and reproduce. That's like everything's perfect. It's in the, and you might hear the word. It's everything is just right. Remember the story of Goldilocks, where she would go to Papa Bear's bowl and it's too hot. Mama Bear's bowl was too cold, but Baby Bear's was just right, and that's what we call the optimum zone. And if you want to call it, you may hear it called the Goldilocks zone. And that's where everything, like I said, just right. And so if we're just outside of that Goldilocks zone, we get into what is called the zone of physiological stress. What that means is that organisms can survive there, but a lot of things are limited. So, again, like the ability to reproduce, to gain size, to become stronger, is severely impacted. Again, they can live in those zones, but it's not where they want to be at. And so, if it's outside of those two zones, which either the optimum zone or the zone of physiological stress, we enter the zone of intolerance. And the zone of intolerance is part of that range where nothing survives, where that organism cannot survive. It will die. So, like, let's look at the bottom here. Let's look at this temperature graph. This is a temperature graph versus abundance of organisms. Notice that this line here, I'm going to highlight that for you, that this line here gives us the number of organisms or the population size as it goes up, comes down. And notice that once we enter the zone of intolerance here, that all the organisms are about none, okay? And notice that most of them want to hang out between these two temperatures. And there's always a high and a low. And a lot of times we talk about temperature, but it can talk about anything. We can talk about air quality. We can talk about precipitation size, precipitation amounts. Any factor that you can think of, we can create a graph like we see here and can find out where most of these organisms live, like from this zone here, and find that optimum range for that organisms. So, if it's healthy, if our ecosystem is healthy, we go through a natural process of ecological succession. And just some things you might want to look at is that ecosystems are constantly changing. They're all the time changing. They're not doing anything else but changing. And so, one thing that we look at is that let's look at something harmful that might be harmful, like a forest fire. But forest fires, what they do is they release or allow nutrients to be put back into the soil, so they're actually recycling the trees that are there, the grasses, whatever dies in that forest fire. And not only that, it also allows for new birth. Like one such plant called the fireweed, it will not sprout unless there is a fire. So like there has to be a fire, it's in the ground, it's ready to germinate, but it needs that heat to release, to let that sprout release. So like sometimes, so sometimes in a fire where it's catastrophic, it can, what we call, disrupt an entire ecosystem, making it uninhabitable for what was currently living there, but it is habitable for other animals to live there. So some new animals will flow in there, new plants will flow in there, and then it'll go through that process of succession. And anytime that change happens, so like changing an ecosystem is like when one community actually replaces the other as a result of changing either living or non-living factors, abiotic or biotic. And that is called your ecological succession. And so that's what we're looking at here. And so the next couple things that we're going to look at is based on succession. So what we start off with is primary succession. And what primary succession is an establishment of a brand new community, and we're starting with no soil whatsoever. So you're basically looking at rocks. You have the rocks, no topsoil, and so like on these rocks you will have certain organisms that will allow themselves to attach themselves to those rocks. Look at lava rock, for example. If you examine newly created lava rock, you might find under a microscope some sort of bacteria and fungi. These organisms are now pioneering into that new community. And so what pioneering organisms do, and that's usually unlike in maybe some mosses that you'll see, what they'll do is they'll attach themselves to the rocks, and through their waste products, and one of their waste products of these organisms is generally an acid. So they dissolve rocks by secreting an acid. And this acid will dissolve the rock. So between that rock being dissolved and those pioneer organisms dying, we start to make new organic material, starting to make that topsoil. And it allows for some plants to start to grow. We're talking stuff like ferns. Okay? And so those ferns grow, they die, they become new soil. And they allow for new plants. So when those initial plants die, it allows for new plants to grow. It newly forms soil and eventually allow larger and larger plants and animals to live in an area. So there comes to a point where everything reaches its peak. Nothing's happening to it. It's just a constant rollover year after year after year after year. And that is called a climax community. And that community is where very little change happens. Okay? And so it goes back and forth within the community, but it just keeps recirculating itself. The same thing's going to be there forever and ever. And so sometimes an ecosystem, that there is sometimes like a natural or maybe even an unnatural disruption will cause the species of a community to be disrupted. So we're looking at some sort of disruption. I think I like the word disturbance better here. And what happens is that all the plants, the animals are wiped out, and we're left with the topsoil. And that is called secondary succession. And it's an orderly, predictable change. Okay? But everything's gone, we have topsoil remaining. Most of these disturbances tend to be caused by floods. Take what happened in eastern Kentucky about a little more than a year ago. Major floods come in, there were some disturbances, but all of that topsoil remains. Could also be forest fires. Think about what just happened in Hawaii. Or sometimes you're looking at winds. And look at what's happening in Florida and in the Caribbean right now. This is hurricane season. Hurricane winds get up to 150 miles an hour, can literally level an ecological community. And so in this case, we don't start with the lichens and the mosses and the really small stuff and work our way. We're kind of like in the middle of everything, and it's usually the pioneer plants or the pioneer species are plants like grasses that grow quickly, just so we can start to get some stability there immediately. So if you notice, if I were to take an acre of land and just raise it to just dirt, the first thing you always see popping up, and fairly quickly I might add, is always your grasses. I mean, if you just think about it, that's the first thing that usually shows up. And so those grasses allow for that topsoil to remain there, allows for some stability, and then over the next years we see trees, we'll see bushes, we'll see maybe some wildflowers or whatever showing up. So again, it all goes to that end point that we're looking for. And so again, once we hit there, we talk about ecological succession, and it's extremely complex. And that complexity allows for those changes to be slow over time. So we're not seeing like these big changes in the environment happening quickly. These are very slow changes. And so many of these endpoints that we're going to talk about are very, very difficult to predict because of the changing rates of organisms. We don't know what organisms we're going to find there. We don't know what's going to happen, and especially if we live close, and I dare say this, humans are a major factor in what happens in the environment. Okay, so like look at what we do. Look at Lexington. You don't see a whole. We have to literally create spaces for parks that could just be parks, just be some dense forest areas, or and have a few trails going through, so there can be some woodlands in our area. But I will be honest with you, humans can greatly change an ecosystem of an area. Like for example, if you look at the summit, I remember 15 years ago, that was just nothing. It was just grasslands. The Hamburg Pavilion. I don't even. When I was driving back and forth to college, it was just farm. There was nothing there, and you see how it's changed in 15 to 20 years. So my big thing is that we as humans need to be aware of how we interact with the environment, because we always need new buildings. We always need resources, and that can include removing mountaintops and other activities. We need to be aware of what we do, because not only does it affect the ecosystems, the animals that live here, but it also affects humans that live in the local area. Specifically, mountaintop removal for coal mining. I know personally people who have had wells affected by taking those mountaintops off and changing the groundwater that's in there. So that's, again, goes back to what I've been saying for a while, is that yes, we should be able to use our resources, but we need to be good stewards of what we are given, and we need to take care of what we have. And I think that's a good place to end. Go ahead and work the assignment that is on the next lesson. That'll come between pages, I do believe 60 and 64. You can pull those questions from there. You guys have a good day.